Hello and welcome back to lecture. Today's lessons we're going to talk about unit conversions and scales. So what is a ratio? A ratio compares values, almost like we were talking about percentages again, right? How much of one thing is there compared to another? And now we can compare across different, I'm going to say, sizes, if you will. There are 3 blue squares to 1 yellow square. And when I'm talking about a ratio, I can talk about a fraction, I can use a word, I can use this colon to represent 3 to 1. That's the same thing as 6 to 2, right? If I had another, if I extended this out to 8, I would have 6 blue for 2 yellows. And it's in that same ratio, that same proportion. Okay? So here it is, there are 3 blue squares to 1 yellow square, and ratios can be used and are shown in a different way. We can use this colon, 3 to 1, use the word 2, 3 to 1, or write it as a fraction. 3 for every 1 is the way that's standing. It's almost like a percentage. Okay. So what would we use ratios? One example is when we represent scaled down images or figures. Scales are real important. If we have a map, we could represent something as here's a distance on the map is equal to 1 inch. Okay, so we'd have a ruler and here's an inch. But what if we went and we took it to a copy machine and we blew this thing up, okay, or to a printer and said I need a bigger picture of this? Then that inch is not the same inch. One good way to do a scale is that if you blow up, you're blowing up this very same scale to the same proportion. So if you go down here, now this is just a scaled up version of this. We would use this to be the miles here. But when you blew the picture up, this would go along with it. And those distances would be the very same as long as you're using, you go to do a tick mark on a piece of paper and then go from one to the other on those tick marks. And every one of those would be 50 miles if you had the full length. Okay. So a common ratio between the real thing versus the scaled item is one way to do a ratio. This could be either a fixed scale or it could be like this. This lets you blow up the map or shrink it, and this would still be the same scale for you for the number of miles per distance. So what is dimensional analysis? Dimensional analysis is basically looking at the dimensions, the feet, yards, inches, and one thing is doing a conversion between those things. So measurement conversions are basically one of the topics that we're going to use frequently and in this series of lectures. If measurements in 2 different units represent the same actual length, then a fraction formed from dividing those units is a way of representing the value 1. Okay. So let's look at an example. I've got 12 inches is 1 foot. Okay. Then I can form a little ratio over this thing, or a fraction, by saying 12 inches is 1 foot, and that distance, really, if you're just looking at it, this distance is the very same thing if I just, did between my, here's, put one hand starting, one hand at the end, 12 inches and a foot is going to be the very same length. So they're equivalent. They're just in different units, different dimensions. Same thing here, I can rewrite this as 1 foot is 12 inches. I've still got the very same quantity length. Okay? Same thing if you had a dozen eggs. If you had a carton of eggs, you'd have a dozen eggs. You'd still have one of those things. Okay? If I had 24 inches, this is how I'm going to use it. I could say, okay, I have 24 inches, and I'm going to multiply this ratio by 1 foot for every 12 inches. The 12 inches is on the bottom, and it's almost like this thing is going to cancel. You know how we cancel common factors in fractions? Inches in the bottom, inches up top. That's inches divided by inches is just 1. And then I'm going to multiply by 24 times 1 divided by 12, which is 2 feet. That's the only dimension that's left in here. What if I have 3 feet? I'm going to use the same equivalent but I'm going to do 12 inches up top, the foot down at the bottom, and the feet are going to cancel. It's the same unit, it's the same dimension. And then I'm going to multiply 3 times 12. There's my 36 inches. Okay, so that little ratio that we formed is building into a conversion factor. Okay, multiplying any measurement by a conversion factor won't change the size of a measurement, but it will change the units of measurement. The goal of converting units is to multiply by a conversion factor in a way that makes the units we don't want to divide out, which ends up leaving the units we do want. Okay. So we're going to divide out the units that we don't want, leave the units that we do want. Okay. So if I've got 1 meter, here's an equivalent measure between two different units, meters and centimeters. And want to build a conversion factor. I could put one side up top, the meters, 1 meters is the same as 100 centimeters. Okay, so this fraction is really 1. Here's another conversion factor that I could write with this very same equivalent statement, is that 100 centimeters is 1 meter. 1 meter is 100 centimeters. 100 centimeters is 1 centimeter. And then if here's another one, 1 inch is 2.54 centimeters. My first conversion factor, I could write it as 1 inch is 2.54 centimeters. That fraction value is just 1. 2.54 centimeters is equal to 1. So 2.54 divided by 1 inch is just 1. I won't change the scale of it, I would say. Okay. So here's an example. I want to convert 25 gallons to liters. Okay. So I want to go to liters. I'm going to start with 25 gallons. That's what I've got, and I want to go to liters. So the 25, this is anytime I want to think about this, this is really a fraction and it's over 1. Can't be anything else. 25 over 2 would be what, 12.5? Okay, so I write this over 1. 25 divided by 1 is 25. And I want the results to be in liters. So I know this needs to be in liters. And this is what I'm going to do. I'm going to go look for a conversion factor between gallons and liters, an equivalent statement. I'm going to build a conversion factor, or just look for conversion factors. The gallons need to be on the bottom. That needs to divide out, and then what's left up top is liters. So I want something liters, and then the per gallons down here. So I go to a conversion factor table, or could look it up on Google, and it comes out that 3.785 liters is 1 gallon. Okay. So now that I've got it, my gallons cancel out. I'm left with my liters, and all I have to do is multiply 25 times 3.785, and the answer would be 95 if we rounded this thing up. Okay. So that's our kind of dimensional analysis of looking for what units we need, dimensions, and we'll see you next time.